Well, here's a good question. Where you're asked to find the coefficient of a precipitate or of the solid at the end. And all you're given are the two reactants. So I've got sodium carbonate, calcium chloride. So let's first write these. That'd be sodium is a 1 plus, carbonate is a 2 minus. So when you balance, sodium carbonate would be written Na2CO3 plus calcium chloride. Calcium is a 2 plus, chlorine's a 1 minus. So when you balance, you need two of these, so it'd be CaCl2. So there's my reactants, and they say these are aqueous. And I can put a little AQ there to indicate they're aqueous. Basically, that means they're dissolved in solution. Now, when you take a look at it, I've got a compound here and another, so a compound here and another compound here. So it's a double replacement reaction. So the sodium is going to react with the, or will replace the calcium and go with the chlorine, and then the calcium goes with the carbonate. So it'll be sodium chloride. Notice I don't bring this 2 along with me, because sodium is a 1 plus and chlorine's a 1 minus, so that compound is balanced as it is. So this is the correct formula for that. Now, I don't know if that's aqueous or not. We'll check in just a second. Plus, calcium goes with carbonate. Let's check that out. Calcium is a 2 plus and carbonate's a 2 minus. So their charges are the same, so they balance out even. So it would be calcium carbonate. And again, I don't know what the state of that compound will be, whether it'll be a solid or an aqueous. So this is where you need to use your solubility table. Let's first look up sodium chloride. And so sodium chloride would be aqueous. Okay, now let's do calcium carbonate. So this one would be a solid. Okay, so what they're wanting is that balanced coefficient in front of the calcium carbonate. So we better balance things. So I take a look here and I have 2 sodiums, so I need to put a 2 there. But that gives me 2 chlorines as well, which I have already. I have 1 calcium, 1 calcium, 1 carbonate, 1 carbonate. So the equation is balanced as it sits. So the coefficients for each of these would be a 1, this one's a 2, and this one here would be a 1. So the answer to the question would be the coefficient in front of the precipitate, or the thing that forms a solid in the end, that number would be 1. Okay, hopefully that helps you with that question. So, sodium chloride, here's our solubility table. And what you do is you look for either sodium or chlorine on this top row. And then you look down to see which one it hooks up with. So sodium, it's a group 1. That means it's in column 1. But here's chlorine is right there. So I could use either this one or I could use this one. It doesn't matter. Then I look down, and this one here, this where it says solubility is very soluble, that means that would be aqueous. And if it's slightly soluble, then that's typically what we call a solid. Okay, so I look at chlorine, and down here, I don't see sodium to hook up with that chlorine. Therefore, it must fall here. Therefore, sodium chloride is aqueous. Okay, so let me go back. Okay, calcium carbonate. I can't really erase stuff. Can I erase stuff? Maybe not, whatever. I'll use a different color. So calcium and carbonate. Again, look up one of those two at the top. Here's carbonate. Let's use that one right there. So when I look down, I've got to look either here or here. So group 1, when you look at the periodic table, group 1 is this first column, and calcium is actually in the second column. So it's not that, nor is it ammonium, so it must fall in that category. Therefore, calcium carbonate is a solid. So look.